Hello there, Algebra 2 folk. This is Chapter 1, Section 6, Solving Compound and Absolute Value Inequalities. And so here for our first example, we have an AND compound inequality. A compound inequality just basically means that you're solving two inequalities at the same time. So for example, we have solve 8 less than 3y minus 7, but also that 3y minus 7 is less than or equal to 23. So to basically explain that, you don't have to do this in your homework, but just to show you what's going on here, I can write this as two separate inequalities. 8 less than 3y minus 7, which is what this part of it says. And also I can write the word and 3y minus 7 less than or equal to 23. So I can actually solve this as two separate inequalities with an and. And what an and means is that you need to find solutions for both equations at the same time. So I can add 7, and 8 and 7 is 15. Divide by 3, and y is, notice that the open part of the symbol is facing the y, so y, if you read it from right to left, we're saying that y is bigger than 5. Or if you read it from left to right, which is normally we do, we're saying that 5 is smaller than y, 5 is less than y. So you can write it in the correct order, making sure that the open side is still facing the y, and that the closed side of the symbol is facing the 5. And this is the same thing. It's kind of like me saying, I am younger than my dad, or I can say, my dad is older than me. So the way that the symbol is read from which direction matters. So y is greater than 5. And then over here, we can do the same thing and solve this guy. And 23 plus 7 is 30. Divide by 3, so y is less than or equal to 30 divided by 3 is 10. So what we're looking for is solutions of the inequality. The compound inequality means when you put the and there, which by the way, the and symbol is this symbol right here. What we're saying is that we want values that are bigger than 5, but at the same time smaller than 10. So you can write this as a sandwich by putting the variable in the middle. It's called like a sandwich. This is a sandwich. It's all one statement as opposed to two separate statements. So we could either say that y is greater than 5 and y is less than or equal to 10. That's one way of saying it. Or we can write it as a sandwich, which when you write a sandwich, you want to put the two numbers in question, 5 and 10, in order chronologically. So the 5 would come first, the y is in the middle, and the 10's on the other side. So it's kind of like you're going to put the y into a sandwich. And then you want to make sure that your symbols still are correct. We have the closed symbol facing the y, and the open side of the symbol facing the 10. And over here we have the closed side of the symbol facing the 5, and the open part facing the y. So what this is saying is that since 5 is less than y, and y is less than 10, then it would make sense that 5 is less than 10. That's the transitive property happening there for you. And so we can write this on a number line or graph our solution. Remember what I said before, you always want to have 0 somewhere. Here's 5, and right about there would be 10. So what we're saying is that we want values that are open, so we want it to be greater than 5, but also less than or equal to 10, so we can close this guy that direction, and it's everything in between. You can also write your solution in what we call interval notation, and when you use interval notation, you would just write 5 and 10. So on one end you have 5, on the other end you have 10, and since this is open, we use a parenthesis, and since the 10 is included, you use a bracket. So basically we use hard brackets for anything that's a closed circle, and the open circles, which used to be open circles, are replaced with a soft parenthesis, and that's called interval notation. So either way is how you can write your answer. So now you can solve these inequalities, and then we will move on to the OR case. So in this situation, we have an OR. The symbol for an OR is actually this union, which is a U for union. And so in this case, you cannot write a sandwich. And I can show you why later. But for right now, you already have two separate inequalities, so that's nice. And you can just solve them separately. So k is less than negative 10. And then over here, divide by 3. And k is greater than or equal to 14/3. Now, we know that any negative number is going to be smaller than a positive number. So, but when we graph this solution set, I just kind of want to show you the difference here of what's happening. We have a 0 here, and then negative 10 perhaps is here. And 14/3, we know that 3 goes into 14 4 times, which is 12. And then, so 14/3 is the same thing as 4 and 2/3. Okay, so then if this is negative 10 and then this is like a positive 10, then 4 and 2/3 is roughly somewhere here. So what we're saying is that we want to be greater than or equal to, so we have a closed dot and we're going this direction. And then for the less than negative 10, it's open and you're going that direction. So what you see here is opposite of what was happening in the earlier example. In the case of the and, your values are going to go towards each other. Your graph is going to go towards each other, and it's like an intersection of the two. But in the case of an or, you actually have the graph branches, if you will, going away from each other. That's very common for an or statement, which is why we can't really write them in a sandwich, and I'll show you why. So here's negative 10, and since we want the symbol to still be accurate, you would have to have the open side facing the negative 10, so you'd have that, and then you would have greater than or equal to 14/3. And the transitive property does not hold in this case as it did earlier, because in this case, you're saying negative 10 is bigger than k, and k is bigger than 14/3, then it should be that negative 10 is bigger than 14/3. But we know that no negative number is bigger than a positive, so this is like not true. So in the case of an or, you never want to write your ors as sandwiches. That is okay to do in the case of an and, because in this case, 5 is smaller than 10, the transitive property holds. But in the case of the or, it does not work, it's not true, so you don't want to put it in a sandwich. So you have to leave your answer as k less than negative 10, union k greater than 14/3. So the last thing we have to do for this problem is to show you how to write that in interval notation. So since this is going on forever, all the way to negative infinity, we write this portion by putting negative infinity to negative 10. And since it's open, you have a parenthesis. And you never, ever put a bracket on the infinity symbol, because infinity is not a number, it's a concept. So it doesn't stop at negative infinity, it just keeps going, it's forever going. So you never put a bracket. And then you have a union symbol, which is the union symbol for earlier. So you're going to union that with the 4 and 2/3, which is basically 14/3. And this time you have a bracket because this dot was nice and dark. It was included. So we're going to put 14/3 to positive infinity. And again, never put a bracket on the infinity symbol. So that would be your interval notation for example 2. Now you can try these guys, and then we will move on to absolute value. So in the case of absolute value, we have ands and ors. In general, generally speaking, when you have a less than, you're dealing with absolute value and you have a less than, it's going to end up being an and. And when you have a greater than, it's going to end up being an or statement. And so what we're doing here is, again, I'm going to show you with absolute value, you have a positive case and a negative case. So we're saying that x is less than 3, that's the positive case, or negative x is less than 3. And because it's a negative x, you can divide by negative 1, and then x becomes greater than negative 3. This leads to our sandwich. If you put this in chronological order, negative 3 comes before positive 3, so you have negative 3, positive 3, x in the middle, and if you make sure that all of your signs are facing the right direction, closed symbol facing the x, open part facing the 3, open part facing the x for this one, so open facing x, and the closed part facing the negative 3. And there's your sandwich. -3 is smaller than x, and x is smaller than 3, and -3 is smaller than 3. This is all very true, so it all works out. And you have an and. When I graph these two guys on the number line, I'm just going to kind of sneak it in here, put a 0, +3, -3. If x is less than 3, I'm going to have open this direction. And if x is greater than -3, and notice again how the graphs are facing each other, going towards each other. So you have that as your intersection. So again, just want to remind you that whenever you have absolute value and it's a less than, your graph should end up looking like an and, in general, 99% of the time. There are a few exceptions, but those will come later. So then we have the or case, and again, you have to do a positive case and a negative case. And you have x greater than 5, or you have -x greater than 5. And again, when you divide by the negative, you switch your symbol and it becomes less than -5. And in this case, again, you cannot write it as a sandwich because -5 would be over here, +5, that would be chronological order. This would be greater than 5. And again, -5 is not bigger than +5. So the transitive property does not hold. And so this is not correct. So you would have to leave it as x greater than 5 or x less than -5. And when you graph that on the number line, you're going to have a 0, a +5, a -5. And so less than -5 would be open dot this direction. Over here we're going to have open dot greater than 5 is this direction. And again, the graphs are going away from each other. And if you want to put that in interval notation, it'd be -infinity to -5, unioned with 5 to +infinity. And by the way, over here, what we have is from -3 to +3 in that case. So that is how you do absolute values, as absolute value inequalities anyway. And so here we have some examples for you to try. And then I have a little bit of a summary for you. You guys can pause the video now and kind of write this down if you'd like. It just summarizes what we just talked about. Pardon the bell. And this is the symbol we use for and, the symbol we use for or. And is only true if both inequalities are true. It's usually an intersection. The graphs go towards each other, kind of give you the breakdown. If you have an and, kind of looks like this. The or, same thing, inequalities going away from each other. So this is something you can write down in your notes. And then also we have the same breakdown for absolute value, that if you have a less than symbol, it's going to be an and if you have a greater than symbol, it's going to be an or. So just some stuff for you to write down. And then we have this example, which is a multi-step absolute value problem. But again, at least for me right now, this is a greater than, so it means that this is going to be an or. So we're going to solve this guy right now. So again, remember that your positive case is 6y minus 5 greater than or equal to 13, or you have 6y minus 5, the negative, for the negative case. So this is my negative case. Alrighty, so here we're going to add 5, we're going to get 6y greater than or equal to 18, divide by 6, and y is greater than or equal to 3. Over here, you can divide by the negative, and when you do that, you get 6y minus 5, and then the symbol is going to change to a greater than -13. A lot of times, people try to do this as one step, and you can do that if you want, but I just choose to do two separate cases. So we're going to add 5, 6y is greater than or equal to -8, divide by 6, y greater than or equal to negative, and 2 goes into 8 4 times, and 2 goes into 6 3 times, so -4/3. And this is my my answer. I'm going to write it in interval notation. So if I want to say, we're going to do the negative one first, we're going to go from negative, it's going to be greater than -4/3. Did I do that right? I'm so sorry, I just noticed a mistake that I made. So I have to go back and fix this. The positive case is correct. I kind of changed the symbol here to a less than prematurely. It should have been a greater than. And that should have been, when I divided by the negative, then it would have gone to a less than. And this would be a less than, and this would be a less than. So I apologize for that. So now this makes more sense to me. So when we have our number line, we're going to put a 0 here, and then positive 3, maybe 1, 2, 3 around here. And negative 4/3 is 1 1/3. So maybe somewhere around here, we're going to have negative 4/3. And so less than or equal to is a closed dot, goes that direction, it's smaller than negative 4/3. And then greater than or equal to 3, again, a closed dot, but going this direction. Makes sense, our graphs are going away from each other like they should. And for our interval notation, we're going to write from negative infinity, no bracket on the infinity symbol, to negative 4/3, and there is going to be a bracket on the 4/3 because it's included. We're going to union that with 3, which is also included, all the way to positive infinity, not included, so parenthesis there. So that's for example 4. And then you have this do-it-yourself problem. And the last example that we're going to do is this guy. Amanda is apartment hunting in a specific area. She discovers that the average monthly rent for a 2-bedroom apartment is $600 a month. That's really cheap. She must not live in San Diego. But the actual price could differ from the average as much as $225 a month. Write an absolute value inequality to describe this situation. I want to remind you guys, we talked about this before in a previous lesson, that you want to have variable minus the ideal, and it can be equal to, less than, greater than, whatever, the distance from the ideal. And from this problem, we can already see that the ideal is that the 2-bedroom apartment is $600 a month. And as far as the tolerance, or the distance from the ideal, it says that it could differ from as much as $250 a month. So it could be above 600 by 225, or it can be below 600 by 225. So it's not going to be very hard. We need a variable, so we're just going to use R for rent. So absolute value of R minus the ideal, which is 600. Pardon that bell again. And we want it to be less than, because it's going to average as much as 225. So this is going to be an AND statement, because we're going to get a range, okay, between this and that. So anywho, less than or equal to the ideal, which, or the tolerance, which is 225. So that's the actual absolute value inequality that they wanted you to write. But now you actually have to solve it. And I know that a lot of you probably already know what the answer is. I guess in your, you can already tell the answer is going to be 600 plus 225 and 600 minus 225. But I just want to encourage you that part of the problem says to write the absolute value inequality. So it doesn't just say give the answer, it wants you to write this expression here. In part B, they want us to actually solve it. So we're going to get R minus 600. This is my positive case, less than or equal to 225. And then I'm going to get and. So also R minus 600. And it's going to be less than or equal to 225. Then I have my negative case here, so I put the negative in front of that. So in this case, I'm going to solve my negative case first, divide by -1, and I'm going to get R minus 600 less than or equal to negative 225. And then when I add 600 to that, I'm going to get that R is less than or equal to, if I can do my numbers here, 375, I believe. Let's just make sure. Sometimes I have brain farts. So 600 minus 225, yay, 375. I might have said 325, I don't remember. But there's that. And then over here for my positive case, we're just going to add 600. That one's easy to do in your head. Shouldn't do the calculator for that one. 6, 7, 8, 25. So when it says find the range of the monthly rent, the range for a monthly rent is that it can be less than or equal to $375 or greater than or equal to $825. But the ideal is that it would be $600. So that is how you do that. And then you have one last example to complete. And once you've done that, you will have completed your notes for this lesson, and I will see you in class. Thank you for watching.